We are on this problem right here. Looks like this, okay? Didn't quite finish this yesterday. This one they give you the equation f of x equals 4x squared. It says over what intervals is the function increasing, over what intervals is it decreasing. So we're just going to start. They actually give you both of the points. You don't actually have to solve anything. If you took -2 and plugged it into 4x squared, you'd get 16. So the point would be -2, 16. You don't have to do any work. They give you both of the points. They give you your x and your y. This one would be -1 and 4. 0, 0 is your next point. 1, 4 is your next point. And then 2, 16. Because what do you notice? If you look at your y values, or your y, these would be right here. Are your y values decreasing or increasing? At the beginning, they're doing what? So y values decrease at the beginning. Okay, 0, 0, we call this the vertex or the turning point. Because that's where it stops decreasing and it starts increasing. So that's why they call it the turning point. It's no longer decreasing. After the vertex, the y values are increasing. Sorry, my handwriting is incredibly bad today. But sometimes when I turn my computer on, it has this pen called the calligraphy pen, and it makes my handwriting look way better than it is. And today it wasn't an option. So now this is just my real handwriting. So, sorry. Okay, so then down here it's fill in the blank. It says the function is, the first blank is decreasing. So that means over the interval where x is less than 0, so if you had x is -1, x is -2, if you had a -3, -4, anything negative, if it's less than 0, it would have been decreasing. And then it's increasing once x is greater than 0. So 1, 2, 3, 4. Anything greater than 0, then your values would be increasing. Okay, so the last question on here is example 3. It's kind of a word problem. It says the owner of a new dance studio is installing wooden floors in all of the dance rooms. How much should the owner expect to spend on flooring for a square room with 15 feet side lengths? And then down here it says write a function to determine the cost of the flooring, price per square foot, and then the area of the dance floor. A lot of this information comes from this picture. So it tells you how much it costs per square foot right here, $8.75 per square foot. So you're going to start your equation with $8.75. That's how much it costs per square foot. And then the area of the dance floor, we're going to use an X for now. This would be, since it's a square room, that's why I put a square after the X. You take your X and you square it, but they actually tell us how big it is. So when you're actually figuring it out, you take 8.75, and then it said both of the side lengths were 15, so you'd replace your X with 15 squared. If you type this into your calculator, you can do it one of two ways. You can just type in 15 squared and then take it times 8.75, or you can type this exact thing in your calculator like that, but you have to have the parentheses if you do that. It's going to end up being 8.75 times 225, because 15 squared is 225. So whatever that is how much it's going to cost to put flooring in all these dance rooms. Anybody know? Yep. There we go. That's how much it costs. The last question says, how much would the cost increase if the side length of the dance floor is increased by 2 feet? So instead of 15 feet, we're increasing that by 2 feet. So it'd be 8.75 times 17 squared, because 15 plus 2 is 17. So 17 squared is 289. 289 times 8.75. What is that? Thank you. Hey, so this is actually not the answer to this question because it asks how much it would increase, how much the price would increase. Obviously, it's more expensive if you add more feet, but I want to know exactly how much it increases from adding the 2 feet. So you would take the bigger number minus the smaller number. What did you say? 560. That is like something that the map test loves to do, or at least just from like some of the problems that we see in our bell work. They get you to a question. Like this question wasn't hard. All you had to do is change it to 17. But a lot of people think, okay, I got my answer right there. The map test loves to change their wording or ask you a question that like you actually have to think a little bit more about. Like if they ask you the cost of the increase, you actually have to find that and not just tell them the answer. So that's like map test loves to do that. They love to like, here's your, you got your answer, but make sure you read the whole thing because it sometimes throws something else at you. Okay, so those are yesterday's notes. We're gonna just go ahead and go right into today's notes. I'm gonna pass these out really quick. We're not going to have an assignment from those notes right there. We'll kind of just start today's notes. So we're starting 8.2 notes, which is all vertex form. You are going to want your Chromebook today. When you get to your Chromebook, you're going to log into the same place we did yesterday, desmos.com. Remember, we're not supposed to be on other sites right now, so that would be not cool if you were doing that and doing like playing chess with someone else while I am teaching you, because your job right now is to be a student. So desmos.com, and then you're going to click Graphing Calculator. The reason we care so much about Desmos is it is going to take way less time to compare your graphs and figure out what they're asking you to figure out if you can just type them in versus actually having to graph everything would take a very long time. So I'm gonna get on Desmos too. And we'll revisit that in a second. So here's your notes right here. We're talking about vertex form today. So The first question, or the essential question, says, how can the vertex form of a quadratic function help you sketch the graph of a function? So they give you 4 different equations. The first one is f of x equals x squared. Then they give you f of x equals x squared plus 2, f of x equals x squared minus 3, and then negative x squared minus 3. So it wants us to compare these graphs together, and then we're going to kind of sketch them. So it says compare your first graph, which is actually right here. They give it to you on the paper. This is f of x equals x squared. That's the parent function. That's the most basic function for a quadratic that you're going to have because the vertex is at 0, 0. From there, we're going to compare all of these other ones to it. So when you add a plus 2 to the end, I'm just going to start by putting in y equals x squared. Even though I know they give me that one on my paper, I'm going to still type that in. And then right below that, I'm going to do y equals x squared plus 2. If you can notice, when you add that plus 2, what happened to my graph? Yeah, the vertex shifted. Instead of being at 0, 0, now it's at 2, 0, 2. So what we will write in this first one is it goes up 2. So if it says plus 2 and that means it goes up 2, what do you think if it says minus 3 is going to happen? It's going to go down 3 from 0, 0, not from 2, but down 3. And 1 second. So we're going to type that in. Instead of saying plus 2 right here, I'm going to say minus 3, and you're going to see how the vertex shifts from 0, 0 to negative 3, 0. 0, negative 3, 0, negative 3. So that goes down 3. The last one was a little different because they make the x negative and then there's a minus 3. So what you'll do, this is the same thing. Watch the blue line when I make the x negative, it flips. So what that is called, when it flips direction, it's called a reflection. So you could say it opens down, or you could say it's reflected. When it switches the way it opens, whether it started up and then it flips to down, that's called a reflection. And then also it is pointing down. And from the first graph, it was down 3. Because we're still comparing it to x squared. So that's a generic thing that you just learned at the end. When it has a plus or minus sign at the end, that tells you how to shift your vertex or where your vertex will go. Let's see. How do I? There we go. Okay, the next one. They give you this other form. They're all in parentheses. This changes things when it's written in parentheses. It's not going to shift it up or down. This is where it's going to change left and right, and you have to pay really close attention here because it's kind of opposite of what you would think would happen. So we already have the first one in there. X squared is already the same. We're going to start by doing x minus 4 squared. That has to be in parentheses. So I'm erasing this. I'm going to start with parentheses and then write x minus 4. Then I have to hit the up arrow. So shift and 6 for me. I think that probably is the same for you. And squaring it. So when I have a minus 4 inside parentheses, it actually moves me to the right 4. You would think, since it says minus 4, that would move it to the negative side. But when it's in parentheses like that, it actually moves it the opposite way to what you would think. So for the first one, we're going to say it shifts it right 4. If you have a minus sign in those parentheses like this one, x minus 4, it's going to go to the right. So what do you think you would do if it has a plus sign? Go to the left. So if we're talking about F3, this would be going left 5 because it says plus 5. I'll show you the graph really quick. I'm just erasing this one. It's going to be x plus 5, and it moves to the left 5. The last one is a minus sign. This one's kind of like the first one. So from x squared, if I have an x minus 7 in parentheses, that's actually going to go to the right 7. And you can check that on your Desmos x minus 7. You'll see that it does go to the right 7. This is all stuff that once you do it a lot of times, you're just gonna remember that. This is brand new information to you guys. You've probably never seen anything like this before. It's the same kind of concept as like translations, rotations, and reflections from 8th grade math, which we will go over before map testing. But if you're confused, use Desmos to help you, and then eventually you'll just catch on to it. Okay, moving on to the next part. This is the vertex form, but we're going to mark this out because I think something is wrong with it because the 2 makes it confusing. So mark that out. There's an error in that. We're going to write it ourselves. This right here is vertex form. A, parentheses, x, minus h. And instead of a 2, that should be squared. That's the reason we're rewriting it. It looks like you took it times 2, but you're actually squaring it. At the end, you put plus k. This is vertex form. I love vertex form. I think it is kind of self-explanatory once you understand what's going on, where H and K stand for your vertex. Then this is kind of just a review of what we just talked about with all these graphs. We're just kind of going back over that really quick. It says if the quadratic function is written as x minus h squared, the minus sign tells us that we're going to move to the right. Like I said, when you're in parentheses like that, you would think that you'd move to the left because it's a minus sign, but it is actually the opposite of what you would think. If the quadratic function is written as x plus h, then the parabola moves to the left. So that's just kind of a review of what we just looked at with all those graphs. Okay, remember that if you have a double negative, so you have minus a -3, that could also be written as a plus sign. The value of A does not affect the location of the vertex. The sign of A affects the direction of the opening, whether that is going to open up or down. If it's negative, your line, or it's going to point down. If it's positive, you're going to point up. The absolute value of A. So absolute value is the distance from 0. If the number is like a really big number, say that the number at the very beginning of your equation is a 10, okay? That's going to affect how wide your graph is. So this is going to say width right here. That very first number is going to tell you how wide your graph is going to be. The bigger the number, we talked about this yesterday. I know there's not very much room, but the bigger the number, the more narrow it gets. So remember, A is greater than 1. So like 2, 3, 4, 5, 20, 100. It's going to be stretched. And let's call it, that means it's just getting more narrow. I wonder if I can fit that. There we go. So if I ever say stretched the graph, that just means it's more narrow than it was to begin with. Now, if your number is less than 1, so like a half, a fourth, or 0.2, 0.1, like any decimal, that means it's going to be compressed or wider than it started with. We talked about that yesterday a little bit. Compressed means wider. And then it says try it. There should be some questions right after on the back of your page. There's a lot of stuff going on here. So we're going to start with the -2. This -2 is not in parentheses. It's kind of like tacked on to the end. That tells you whether you're going up or down on your graph. This is straightforward. You don't have to do the opposite of what it says. So if it says -2, that means your graph is going down 2, or your vertex moves down 2. Now this one that is in parentheses, this is where you do the opposite. The one in the parentheses, you do the opposite. So if it says +1, you'd go to the left one. The next one has even more going on with it. So we're going to start by talking about the negative sign. The negative sign means that there is a reflection. Instead of it opening up, it's going to actually point down. The negative sign tells me that this is going to point down. The 3, since that number is greater than 1, that means, and if you go back, we wrote that down, if it's greater than 1, it's stretched or more narrow. So we're going to call that stretch. I spelled that wrong. Let me put that there. Now we're going into the parentheses. You've got, I think it says -5. Yeah, x -5. That means this is going to go to the right 5. And last but not least, at the very end, we have this +7. That is very straightforward. It tells you whether you're going up or down. Positive means up, negative means down. Since it's positive, that means I'm going up 7. So there's a lot of stuff that happens when they change the equation from just x squared, okay? Because the parent graph of this is y equals x squared. This is telling us when we add all these other things to it, what happens? There's a reflection. It's going to be more narrow. You move the vertex to the right 5 and up 7, okay? So there's a lot of stuff that happens. And now we're going to practice actually graphing and what that looks like. So remember, your function that you always start out with, this is called the parent function. The most basic function is y equals x squared. They're taking that function and they're changing it, and we're going to graph it, okay? So the step 1 is we need to identify the vertex. Okay, so you're going to go in and look, and remember the vertex is H and K. H, I'm going to go back so you can write that down. I'm going to go back to our equation. Here's our equation. This is what I'm looking at right here. You see how it says -h? That actually means the opposite of h. So that means instead of writing exactly what's in parentheses, we want to do the opposite sign of that. So in this case, it says +1. What's the opposite of +1? -1. So that's our h is -1. And then k, it's the very end number, and it's the same sign as what it is on the problem. So if this says +5, your k is a +5. That is the vertex, and we're going to graph it. So we're going to go to the point -1, 5. That's our first point. So that was step 1. Step 2, plot the vertex. We just did that. And axis of symmetry. I'm going to abbreviate that. Okay, so you know that the axis of symmetry from what we learned yesterday goes through the vertex. So here is where our axis of symmetry is. I'm going to draw a dotted line through that. It's just the line that goes through that vertex that we just plotted. That line is actually called, in this case, x equals -1. Okay, so we don't have a graph yet because all we have is 1 point. We're looking for a parabola, which means it's going to have like a U shape or an N shape. So the step 3 is we want to calculate, oops, I just messed up that. Calculate 2 points on one side of axis of symmetry. So we're going to replace x with whatever we want as long as it's going to fit on our graph. If I look, I have 0, 0 right here. I'm going to put a 0 in for x into my original equation. So I'm going to show all my work here. I started with a -2, and then I had those parentheses. I'm replacing x with 0. And then everything else I just write exactly the same. And then I can solve when x equals 0. So I know that I'm going to actually write my little ordered pair right here. X is 0. Now we're trying to figure out what y is. So order of operations tells us to do parentheses first. What's 0 plus 1? What is 1 squared? What's 1 times -2? And what's -2 plus 5? So the point when x is 0, y is 3. We're going to plot that point. 0, 3. I'm going to go over 0, up 1, 2, 3. There we go. We need one more point, so we're going to make x equal to 1. We're going to do the exact same thing, except for where x is, now it turns into a 1, not a 0. Everything else stays exactly the way it was in our original equation, except for x turns into 1 now. Order of operations says we'll do parentheses first, so what's 1 plus 1? What's 2 squared? What's 4 times -2? And what's -8 plus 5? Okay, so the point here, we made x1 and we got -3. So we're going to plot that. We go over 1 and down 1, 2, 3. So we have one side of our parabola done. The other side is really easy because of this axis of symmetry. All you have to do is reflect the points across the axis of symmetry. You don't actually have to solve the points on the other side unless you just feel like it. How you do that, my axis of symmetry is this dotted line that I drew. I'm going to count how far away my point is from that dotted line. In this case, it's 2 away on this side, so I'm going to go 2 away on the other side, and I'm going to make a point. Right here, my point up at the top was 1 away from my axis of symmetry, so I'm going to go 1 away on the other side and make a point. All you have to do now is connect your points to make your parabola. Mine's not very good, but there you go. Now, that was kind of exaggerated. Like, I typically would not spend that much time on one of these problems. If you type this into Desmos, you should get the exact same graph that we just graphed. So you're always able to check your work on Desmos. I don't mind that. Just realize that when it comes to test time, you don't get Desmos. You have to know how to graph this on your own. So if you're using Desmos to do your homework, which, I mean, it is your resource, you can do that, realize that when it comes to test time, you don't get to do that, okay? We're going to practice 2 more. We have about 5 minutes, so it'll be about perfect. 2 more graphs, and then we're going to be done for today. So the first thing you want to do, and I'm just going to kind of Is it on your paper? Very back. Okay. The first thing you want to do is you want to write your vertex, and remember your vertex is H and K. You're going to do the opposite of the sign in the parentheses. So this first one says +1. That means my first point is actually a -1. I do the opposite of the sign in the parentheses. Now my K is normal. Like I just used the exact number that they give me at the very end. It's a -4. So I am now going to start by plotting that point on my graph. I'm going to go over -1 and down 1, 2, 3, 4. That is my vertex, which means my axis of symmetry goes right through that point. I'm drawing that little dotted line. The points are all the steps are written out for you right there if you want to follow them. But for the next thing, all you need to do is come up with 2 points on one side. I'm going to make x 0. So when x is 0, what is y? Let's go ahead and plug a 0 in. 0 plus 1 is what? What is 1 squared? And what's 1 minus 4? Okay, so my first point on one side is 0, -3. I go over 0, down 1, 2, 3. Make sure you're staying on the same side of the axis of symmetry, or else you're it's going to take a little bit longer. I'm going to do x equals 1 now. So I know that my first point is going to be 1. I'm going to plug that into x in my equation. So 1 plus 1 is 2. 2 squared is 4. And 4 minus 4 is 0. So when x is 1, y is 0. So I'm going to start at 0, 0. I'm going to go over 1, and I'm not going to go up or down anything. Now all I have to do is reflect those points. So since they're both on the right side, I'm going to count how far away they are from the axis of symmetry. This one is 1 away, so I go 1 on the other side, right there. This one is 2 away, so I stay on that same line that it is on, and I go 2 to the other side. That's just a reflection. I connect my points, and my parabola is done. So it really doesn't take that long if you're not writing out all those steps. And you're always able to check your work on Desmos. Last one before the bell rings, we're going to start with the vertex. Remember, the one in the parentheses, you have to do the opposite sign. So since that says -2, my first point of my vertex is +2. This is a +1, so this stays +1 for my second point. I'm going to go ahead and graph the point 2, 1. That's my vertex right here. That means my axis of symmetry goes right through that. You just need to pick 2 points on one side. I'm going to pick 0 and 1. They're both on the same side. So when my x is 0, 0, is that a -2? -2 is -2. -2 squared, what's that? 4. 4 times -3. And -12 plus 1. -11. Is that going to fit on our graph? No. Okay, sometimes that happens. So then I'm going to try 1 and see what happens. 1 minus 2 is -1. -1 squared is just 1. 1 times -3 is -3. And what's -3 plus 1? There's a point that's actually going to fit. We're going to go over 1, down 2. We know that the other point's going to be way down here, which means there's nowhere I'm going to have another point. So I'm just going to reflect this one, and I'll only have 3 points on this parabola. All right, you guys, that is your notes for today. You can put your stuff away. Make sure you keep bringing your Chromebook back to class, because I think using Desmos is going to help you. We will do some homework over this section tomorrow.